Hey everybody, this is Mr. Ainsworth here. We're in lesson 4.8 here in Algebra 1 at Great Oak High School, Applications to Inequalities Part 2. In the first part, I solved all these problems here, going over the basics of systems of inequalities. Here in numbers 3 and 4, finding the system given the graph, which is the opposite process. And then I also did number 5. I talked about that as well. So here, we're going to solve a couple word problems. All right, which is the application of inequalities. So let's read through it and let's go for it. A juice shop here has 144 fluid ounces left of orange juice here to fit in the jars 12 ounce and 16 ounces. They need to earn more than $33.50 from the juice. So, obviously there's a little sale going on here and you're trying to make money. Let X represent the number of 12-ounce jars that you're going to put the orange juice in, and Y represent the number of 16-ounce jars. Okay, they earn when they sell the jars $2.50 for each 12-ounce jar. They earn $4.50 for each 16-ounce jar, which is why we got to write a system of inequalities that represent the constraints. This word constraint here means limitation because there are limitations in this problem, as you're going to find out. We're going to graph the system of any equations here or inequalities. And of course, we got to answer the question. Okay, so there's obviously some work to be done. Okay, so let's visualize this here. All right, so we have 144 ounces of orange juice total. Okay, that is all we got. All right, so in this, let's say we have this big container. All right, let's just do big container. We have 144. They're actually fluid ounces here, so I'm going to go fluid ounces here. Total, all right, OJ, all right? That's this part. Now, what we're going to do is we're going to put some in the small jars, 12-ounce jars, little jars here. All right, let's do little jars right here. And another one, the big 16-ounce jar. All right, okay, so we have 12-ounce jars. We got 16-ounce jars, small ones. All right, we got big ones. Okay, you can see this in your kitchen, or if you talk to your parents here, you can see it in cans, all kinds of things, glass jars, cans, all kinds of things. There's 12 ounce, 16 ounce, 22 ounce. Okay, so you just got to, be familiar with what's in the kitchen. And so what we're going to do is we're going to fill these jars up and we're going to sell them and we're going to make some money. All right, they need to earn more than. Ooh, look at these keywords. More than, okay, greater than. That symbol is greater than, as you guys hopefully know. Okay, more than $33.50 from the juice sales. Okay, so how do we set up a system of inequalities to represent this situation? And how do we answer this question down here to meet all the constraints or limitations in the problems? Because we only have 144 ounces, and that is a maximum. Okay, and whenever you have a max or a min, which in this case we do, okay, so I'm going to write down max. That is called a constraint, a limitation, which is either a maximum or a minimum. Also, we need to earn more than $33.50. Well, guess what? That is a minimum. Okay, so whenever you have maximums and minimums, you have inequalities, and what you can do is represent them using the inequalities and solve all kinds of problems. It's really cool. So now let's kind of go further here. Let's detail some things out. So it says X up here is going to represent the number of 12-ounce jars. So number of 12-ounce jars. Y is going to represent the number of 16-ounce jars. So in order to solve a problem, you have to fully understand it. So you kind of diagram it here. And then try to solving here. So with two unknowns, with two variables, okay, usually requires two equations or inequalities. Okay, so let's talk about how we use this 144 ounces first. Okay, so if we sell one 12-ounce jar, we're going to use 12 ounces of the total 144. If we sell two of them, All right, we sell 24, we sell two jars, small 12-ounce jars. Well, guess what? We're going to use 24 ounces. 2 times 12 is 24. Well, the the case is on the other one here. If we sell one 16-ounce jar, obviously we use 16 ounces. Two times 16 is 32 ounces, and so on. All right, but we can max out at 144. So we don't know how many jars we should sell to maximize our profit here of sales. All right, but we do know that if we sell X jars of the 12 ounce, we're going to use 12x ounces. All right, that's the total fluid ounces of the small ones. All right, plus we're gonna use 16 times whatever Y is ounces of the big one here of orange juice. Okay, this is the amount of OJ. So OJ in the small ones plus the OJ in the big ones, that's got to be less than or equal to 144 ounces total. Again, this is a total, and it's a maximum. And whenever you have a maximum, it's got to be less than or equal to that. That's why I use the less than or equal to here. All right, so the amount, all right, of OJ in the small ones plus the amount, AMT is amount, okay, of OJ in the bigger jars has got to be less than the total, okay, total OJ. All right, that's where that equation comes from. Okay, so next equation, we got to check money here. We earn money for every jar that we sell. So if we earn 250 for every jar that we sell, and we're selling X jars, then we're going to be earning 250 times, whatever we sell. So you want to multiply that. And that's for the small. This is the total money brought in. The money brought in by the small jars. And then the money brought in by the bigger jars, well, that's 450 per jar times the number of jars, Y, and that's going to be the money brought in by the bigger jars, the 16-ounce jars. So in terms of our money equation here, we gotta have money equation. All right, we're gonna have 250 here times this number of small jars plus 450 times the number of big jars, and that's got to be greater than, because we want more than, okay, look at the wording there, greater than, more than $33.50. And there, my friends, is what's called the system of equations describing the situation. And then asks us to graph the constraints and then answer the question below. Okay, so now we got some work to do because these are not the simplest equations on the planet. So I got to take them over here. I'm going to take the first one, 12x here plus 16y is less than or equal to 144, and we gotta isolate y here so we can graph it. Okay, so now here we're going to subtract 12x. We've got 16y is less than or equal to negative 12x plus 144. Okay, divide by 16. Now, if you guys are with me in class, I would, or even at home, I would say, use the calculator when appropriate if you need it. Like right here, negative 12/16. Divide both of these by 4 and you get negative 3/4 x. There's your slope. And then 144 divided by 16, that's 9. If you don't know that, then just use a calculator. And that's our first equation. Okay, next one. We got 250x plus 450y. All right, is greater than $33.50. And I need to solve for y here, so I'm going to subtract. Now I'm going to subtract 250x on both sides. So I've got 450y is greater than negative 250x here, all right, plus 33.50. Now, this is a video, right? And if you're watching this at home, if I'm going too fast, don't worry about it. Just pause and rewind and listen to it again until you get it, right? Okay, So now, got to divide here. Divide everything by 450, and this is where it gets fun. Okay, so what do we have? We have y greater than something. Now, here we go. Let's bring in a calculator here. Now, you got to be careful when you use a calculator here because negative 250 divided by 450, if you just type it in, you get negative 5.5 repeating. And my friends, that is not the same as negative 0.5, not the same as negative 1/2. So be careful. This is a repeating decimal. But we need a fraction. Okay? Huh. Look at that. Decimals gives you the fraction. That is amazing. I didn't know it did that. I just learned something right now. I just thought of it. So this 2.5 divided by 4.5, that's a repeating decimal. And notice how it's negative 5/9. So if you don't know that, so let me talk about how to get that by hand because that's kind of cool. All right, so let's take this right here and let's bring it over here. All right, so negative 250 times 450. How do you get negative 5/9 by hand? Well, the first thing you do is you multiply both by 100 and shift the decimal. Okay, so the first thing we're going to do is going to multiply by 100 on both and shift the decimal. So I get negative 250 divided by 450. All right, when you multiply by 100, you just shift the decimal place twice. Simplify. All right, and now we look at this. You get negative 25 over 45. And then if you divide both by 5, you get negative 5/9. Okay, so I know just by using some mathematics, okay, some arithmetic here, that my slope is negative 5/9. But what in the world is this? So let's bring this in here. Let's work this out. So 3350 divided by 4.5 or 4 point, okay, is 7.4 repeating. Now this right here to get a fraction is a little bit more difficult. All right, but it's okay. That's okay. That's all we need. So now what we want to do is we want to graph these bad boys. All right, so take a look at the first equation here. All right, so it's y less than or equal to negative 3/4 x plus 9. And so we're going to plot at 9, obviously, because it's a y-intercept. That's a b value. Then go down 3, right 4, down 3, right 4, down 3, right 4, and you should end up at 12. Okay, and then you draw the boundary line, like so. All right, and it's less than or equal to, so you shade below, and all the solutions are below. Okay, and so the first inequality is in red, the second one's going to be in blue. Okay, so how do you start this one? So 7.4 is obviously close to 7.5. And then I'm going to go negative 5/9. So that's down 5, right 9. So down 5. 1, 2, 3, 4, 5, right 9. And then if I do that again, you're off the grid. So don't worry about that. So here we go. Okay, so there's the second one. So now that one there is greater than, so we shade above. So we have to be above the blue line and below the red line. And if you're above the blue line and below the red line, you're in between the lines. Okay, and notice that I didn't shade to the left of the y-axis, okay? And the reason why, and let's make a note of this in green here, okay, the solutions cannot be negative. Okay, and if the solutions can be negative, you can't be left of the y-axis. So only in the yellow region are the solutions. Okay, so now we have the full problem here. So we have how we isolated one on the right, we got our system, we have our graph. Now we can answer the question. Okay, what is a possible combination of 12 ounce and 16 ounce jars that can be made to meet these constraints, limitations. Okay, well, you got to be in the solution region. So one possibility, if you zoom in here, if you find it here, is this point right here. It's in the solution region. And guess what? That's 2 comma 7. So 2 comma 7 is a solution, but what in the world does it mean? So then you go back to the problem and start reading again. At the top of the screen, it says let X represents the number of 12 ounce jars. So I need two 12 ounce jars. And it says up at the top of the screen, Y is the number of 16 ounce jars. Well, I need 7, all right, 16 ounce jars. That's one possibility. What's another one? Well, you just pick a point in there, guys. All right, and how about this one right here? So that's 1 comma 8. So 1 comma 8 is also a solution. Guess what? There's more than one solution here. So one 12 ounce jar, okay, and 8 16 ounce jars. There we go. And that, my friends, is what you guys are going to be expected to do when you problem solve and on the exam here. You have to be able to isolate Y. Well, first of all, step one, you have to be able to interpret it as a system. That's a big step. All right, so step one, set up a system. Step two, solve for Y in each. Step three, graph. And step four, interpret. All right, so here we go. Let's write down the steps. Step one, all right, form a system right here. All right, step two, isolate Y so you can actually graph. Step three is graph the system. Okay, and step four is interpret and find solutions by looking in the solution region. Okay, and that right there is on the exam. It's a major part of it, and this is what you want to get good at. So if you're going to study, this is what you need to study. Practice this a few times on your own, because there's one thing working with me in class, it's another thing working in your group, and it's a totally different thing working on your own, and that's what you guys got to realize. You got to go home and internalize it in practice. All right? So hopefully that helped you out. I'll do the next one in my next portion of the video here, and hopefully you're in class, because guess what? We do everything in class. All right, I'll see you then. Take care. Bye-bye.